Hi, hello, welcome back to the Math Club, Matthew, where you'll get content based on math for class 9th and 10th. In our previous video, we discussed about types of numbers and their relationship and how to prove root 2 is irrational. If you have not watched that video, please check it on our YouTube channel. In this video, we'll be discussing about how to represent real numbers on number line. Now let us get to know how to represent real numbers on number line. So before that, we know that among real numbers there are two kinds of numbers. One is rational number and another one is irrational number. So there are different ways of representing both rational and irrational numbers on number line. So first let us learn how to represent rational numbers on number line. We know rational numbers may be of different types. For example, 2 by 5 is this a rational number? Yes, because it is written in the form of p by q, where p and q are integers and q is not equals to 0. Now, I can write 2 by 5 also as 0.4. So here 2 by 5 is also a rational number, 0.4 is also a rational number. This 0.4 is not written in the form of p by q, but is written in the form of a decimal, but still we consider it as rational number itself. And there are different ways of representing these both the numbers on the number line. Even though they are equal to the same number, there are different ways of representing a fraction and a decimal number on the number line. Let us get to know both of them one by one. First, let us try to represent 2 by 5 on the number line. So everyone knows real number line. Yes or no? Real number line. How does a number line look like? This is called as a real number line. Why is this called as a real number line? Because all the real numbers, both rational and irrational numbers, can be represented on this line. So we call this as a real number line. Real number line. Now let us try to represent the rational number 2 by 5 on this number line. Here we have numbers such as 0, 1, 2, 3, 4 and -1, -2, -3. But where is 2 by 5? How can I find this? Now if I want to represent 2 by 5, so I'll draw the number line quite bigger. Let me take 0 over here, 1 over here and 2 over here, -1 over here and so on. See, I have 2 divided by 5. So I have a whole divided into 5 equal parts. What is the denominator here? 5 equal parts. So what I am going to do now? Now I am going to divide this 0 and 1, the place between the number line between the 0 and 1, into 5 equal parts. I have to divide this number line between 0 and 1 into 5 equal parts. So to divide it into 5 equal parts, I'll put 4 lines over here. One less. Suppose you want to divide, then this part 0 to 1 into 5 equal parts, I will put 4 lines in between. Check. 1, 2, 3, 4. Now check the number of parts. This is 1 part, 2 parts, 3 parts, 4 parts, 5 parts. So I put 4 lines in between and I got 5 parts over here. Similarly, if you want to divide this line into 10 parts, you need to put 9 lines in between. If you want to divide it into 20 parts, you need to put 19 lines in between, just a line lesser than that. So here this is called as 0. The first line which I drew is called as 1 by 5. The second line which I drew is called as 2 by 5. The third line which I drew is called as 3 by 5, 4 by 5, and the next line, see, 4 by 5, the fourth line which I drew is called as 4 by 5. Then this fifth line, the next line is called as 5 by 5. You can see 5 by 5 is nothing but 1 itself. If you simplify 5 by 5, we'll get again 1 itself. Yes or no? That means we are going on the right track. So now I'll divide the space between this 1 and 2 also into 4 equal parts. 1, 2, 3, 4. Sorry, 5 equal parts by putting 4 lines in between. So this is 5 by 5. The next part will be 6 by 5. This is 7 by 5. This is 8 by 5. This is 9 by 5. And this is 10 by 5. You can see 10 by 5. 10 by 5 if you simplify you will get again 2. That means we are exactly correct. So we want to represent this 2 by 5 on the number line. So I got it over here. If you wanted to represent this 7 by 5, here it is. Then 9 by 5, all the numbers can be, and this can be extended infinitely. See here in the number line we always have this arrow mark which represents the number line can be extended infinitely. So there is no end for numbers even on the number line. So this is how we'll represent a fraction on the number line. Now let us take an example of representing a negative number on the number line. Now let us try to represent minus 5 by 4 on the number line. So for that also I'll draw the same number line. I'll draw 0 over here. If you look at it, it is a negative number. So we have negative numbers towards this side, towards the right side of the number line. So what we'll take here, we'll take minus 1, minus 2. This is our main part which we are going to use now. This 1, 2, simply we can write it. Okay. So I have minus 5 by 4. I have 4 on the denominator. So I have to divide this lane between 0 and minus 1. Since it is a negative number, I am taking it towards this side. If it is a positive number, I would have taken this side. So I have to divide this lane between 0 and minus 1 into 4 equal parts. So to divide it into 4 equal parts, how many lines should I put? 3 lines, exactly 3 lines. So I'll put 1, 2, 3 lines in between. I'll put exactly 1, 2 and 3 lines in between. So now the numbering we have to start from 0 always. In the previous examples we started from here and went towards the right. Here we'll start from 0 and went towards the left. Are you able to understand? So I'll start here 0 and the first number will be minus 1 by what is the denominator? 4. Next, the next number will be minus 2 by what is the denominator? 4. The next number will be minus 3 by 4. The next number will be minus 4 by 4, which is minus 1 itself. Minus 4 by 4, if you simplify, you will get again minus 1 itself. Now I should again divide this. See, still I did not get the number minus 5 by 4. So what I should do? I should again divide this lane between minus 1 and minus 2 into 4 equal parts by putting 3 lines in between. 1, 2, 3. The next line will be minus 5 by 4, minus 6 by 4. So here we got minus 5 by 4. This is how we'll represent a fraction or a rational number in the form of a fraction on the number line. Now quickly pause the video and try to represent the numbers you are looking on the screen on the number line. Hope you all are clear how to represent a fraction or rational number in the form of a fraction on the number line. Now let us try to represent a decimal number on a number line. Even decimal numbers are also rational numbers. So let us look how to represent these kinds of numbers on the number line. For this also we are going to draw the same number line, starting from 0, 1, 2, 3, here minus 1, minus 2, etc. So we found a number line. So 2.56. If you look at 2.56, you will get an idea that 2.56 lies between 2 and 3. Yes or no? So 2.56 obviously lies between 2 and 3. You all have an idea about that. So what I should do, I have very less space in between 2 and 3. So what I will do, I will magnify this number line between here. I'll zoom it out here. I don't want this part of the number line. I want only this part of the number line. So what I will do, in between this, the lane between this 2 and 3, I'll magnify it. Look here. I'll draw one more number line such that 2 is over here and 3 is over here. Okay, so now so 2.56 lies between 2 and 3. So whenever you are representing decimal numbers on number line, I have to divide this lane between 2 and 3. This lane between 2 and 3, which is zoomed over here, into 10 equal parts. So if I want to divide this lane into 10 equal parts, how many lines should I put in between? Yes, exactly 9 lines. So I shall put 9 lines in between now. 1, 2, 3, 4, 5, 6, 7, 8, 9. So in between 2 and 3 I have put 9 lines, so it is divided into 10 parts. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So now let us start numbering. From here, this is 2 means 2.0, which can be written as 2.0 also. The next part is 2.1, the next is 2.2, 2.3, 2.4, 2.5, 2.6, 2.7, 2.8, 2.9 and 3.0. So if you look at 2.56, you will get an estimation that it lies between 2.5 and 2.6. Here it lies between 2 and 3. If you are magnifying 2 and 3, you will get these many numbers in between, and here we are having 2.5 and 2.6. So 2.56 lies between 2.5 and 2.6. We will magnify this again. I will start from here. This is 2.5 and this is 2.6. Now what I will do, I again divide this line into 10 equal parts. To divide it into 10 equal parts, I will put 9 lines in between. So I will put 1, 2, 3, 4, 5, 6, 7, 8, 9 lines in between. So starting from here, this is 2.5 can also be written as 2.50, 2.6 can also be written as 2.60. This is 2.50, 2.51, 2.52, 2.53, 2.54, 2.55, 2.56, 2.57, 2.58. So we wanted to represent 2.56, here we got it. So this is how we'll represent decimal rational numbers in the form of decimals on the number line. If you want a negative number, you can zoom the part towards this side of the number line and you can do the same process. This can be done for any number of, it can be done up to any number of decimal points and any number of digits after the decimal points. Now quickly pause the video and try to represent these numbers on the number line. So now let us see how to represent irrational numbers on number line. Before that, let's recall what are irrational numbers. We define irrational numbers as those numbers which cannot be written in the form of p by q, where p and q are integers and q is not equals to 0. In simple form, those numbers which are not rational are called as irrational numbers. For example, square root of n, where n is a non-perfect square number, except square root of perfect squares. All non-perfect square root of all non-perfect square numbers like root 2, root 3, root 4 does not come into account. Root 5, it is a rational number because root 4 is equals to 2, it is a rational, so it does not come into account here. Root 5, root 6, root 7, root 8, root 9 again does not come because 9 is a perfect square. Root 10, all these kinds of numbers are irrational numbers. Now let us try to represent these kind of numbers on the number line. First let us try to represent root 2 on the number line. To represent root 2 on the number line, first I will draw a number line. -1, 0, 1 and 2. Okay, so representing root 2 on the number line involves a lot of steps. In your exams, you may also be asked to write down the steps involved in the process. So simultaneously, let us also write the steps which we are using to represent root 2 on the number line. So first let us understand a basic idea. How to represent root 2 on the number line? See, you may get numbers fractions easily by just dividing a lane into different parts. Okay, but root 2, how can we get root 2 by dividing this line into certain parts? For that we will use Pythagoras theorem. If you remember, what does Pythagoras theorem says? Pythagoras theorem says in an right angle triangle, I'll take it this way, in an right angle triangle, if this is the base of the triangle, this is the height of the triangle, and this is the hypotenuse of the triangle, base square plus height square is equals to hypotenuse square. You all know this, right? If you take the base, square it, take the height, square it, add both the squares, you will get it equivalent to the hypotenuse square. So this is all known. So we will use this principle over here. So now look at the example which I am giving. So to get root 2, what I will do, I will take a right angle triangle whose base is 1 unit and height is also 1 unit. Now use Pythagoras theorem to calculate the hypotenuse of this triangle. So we know by Pythagoras theorem, base square plus height square is equals to hypotenuse square. What is the base of this triangle? 1 unit. So 1 square plus what is the height of this triangle? 1 unit. So 1 square is equals to hypotenuse square. Hypotenuse, what is the hypotenuse? We don't know, we'll keep it as it is. Okay, now 1 square is 1, 1 square is 1, 1 plus 1 is 2, 2 is equals to hypotenuse square. So if hypotenuse square is 2, what is the value of hypotenuse? If I do square root on both sides, I will get 2 is equals to square root of 2 is equals to hypotenuse. Are you able to understand? So the length of the hypotenuse will be square root of 2 units. But this is not on the number line, so we'll represent. So to get square root 2 units, a line segment of length square root 2 units, we formed a triangle whose right angle triangle whose base is 1 unit, whose height is 1 unit, then we got its hypotenuse is root 2 units. Let us do the same thing on our number line. So first what I will do, starting from 0, I will take 1 unit. Okay, I will call this as AB. So you can also write the steps involved. Okay, we'll write the steps. We will make one more video in detail to write it along with the steps. Now let us discuss how to write them. So what I will do, I will take this as 1 unit length over here. I will take this as AB. Okay, now I took the base as 1 unit. This is AB, 1 unit. This is C. Now I will take BC perpendicular to it with the same 1 unit length. Use scale and pencil whenever you are drawing this. So I took the base AB as 1 unit. Now I will take this height BC also 1 unit, exactly perpendicular to it. Now I will join this over here. So we calculated here, if the base is also 1 unit, height is also 1 unit, what is the hypotenuse? Root 2 units. So of course this will be root 2 units. This hypotenuse AC will be of root 2 units. So now what I will do, I will take a compass with pencil. I will keep the needle of the compass here. I will keep the pencil of the compass here. I will draw an arch until it exactly falls on the number line. So this point where it falls is root 2, square root of 2. This is how we'll represent square root of 2 on number line. So in the similar way, we can also represent square root of 3, square root of 5, square root of 7, all such kind of irrational numbers on number line. I'll make a separate video for that along with the steps involved. Now, hope you have understood square root of 2 on number line, how to represent square root of 2. Hope you have understood how to represent square root of 2 on number line. Make sure you are doing it once again, but just looking will not help you, my dear children. What you have to do is you have to do it practically by yourself. I'll make one more video to represent square root of 2, square root of any non-perfect square number, that is irrational numbers on number line. Thank you.